Introduction to GeoPandas, Shapefiles and Maps. GeoPandas helps us analyze and visualize geographic data in Python, like locations, boundaries, and real-world maps. In this lesson, we will understand geospatial data basics, read and inspect shapefiles, plot simple maps, explore a real-world mapping mini-project. You do not need previous experience with GIS or mapping. Let us get started. Running the cell now. Here we import Python's warning system and ask it to ignore warnings. This keeps output simple and uncluttered for beginners. This suppresses warning messages to keep our output clean. Running the cell now. What is geospatial data? Geospatial data is information connected to locations on the Earth. Points show places, like schools. Lines show paths, like roads. Polygons show areas, like city boundaries. This type of data helps us answer questions about where things are and how they relate on a map. Running the cell now. We make sure GeoPandas is installed for mapping. This code checks your system and installs GeoPandas if needed. If you already have it, you can move on. Running the cell now. Here we import GeoPandas for maps, Pandas for tables, and Matplotlib for charts. GeoPandas is GPD, Pandas is PD, and Matplotlib plotting uses PLT. These are common short names you will see elsewhere too. Running the cell now. What is a shapefile? A shapefile stores map shapes. Points, like post office locations. Lines, like rivers. Polygons, like country borders. Shapefiles usually have the .shp file plus other helper files. GeoPandas can read them easily. Running the cell now. We are downloading a shapefile with all US state boundaries. The file is zipped to save space. We download it only if we do not already have it. The link points to public census data. Here, OS helps with files. We name our zip file for storage. If it is not found, we grab it with erlib. Now we read the zip directly using GeoPandas. GeoPandas loads it with gpd.read_file using the zip path. We print the shape to see rows and columns. We show the first lines as a preview. Running the cell now. Try changing the file name to see what happens if the file does not exist. The data we load is called a GeoDataFrame. It looks like a table, just like a spreadsheet. But it adds a special geometry column for map shapes. Here we print all columns. Running the cell now. Now we plot the boundaries on a map. We use gdf.plot to draw the shapes. We add a title for clarity. plt.show displays the picture. Running the cell now. You can try changing the color or the fig size to see different effects. Filtering geospatial data. Sometimes, we only want certain rows. For example, we might only want Western states. Let us see how to select by state name. Running the cell now. We list abbreviations for Western US states. We filter the main table to rows in our list. Now we plot this smaller map. We keep the edge in black and fill states with orange. Adding a title helps us know what is shown. Let us show the map. Running the cell now. Try creating your own list for other groups of states. Maps can have labels for clear reading. Here we plot and then loop over states to add their names. We use the middle of each shape, called centroid, for label position. Text size adjusts for space. We add a title as before. Now the map will show both boundaries and names. Running the cell now. What if there is an error? GeoPandas might give errors if a file is missing or uses the wrong path. You can check file existence with Python's os.path.exists. Check column names if you get a column error. Running the cell now. Now let us interact. Type any valid state abbreviation. Input is a short code, like CA for California. We check if your entry is in the US states. If yes, we filter and plot that state. A small green map shows your choice. The title shows your abbreviation. We display the map. Otherwise, we show a polite not found. This lets you explore the data interactively. Running the cell now. Try typing NY or TX for fun. If you try ZZ, you should see the not found message. We can add new columns to our data. Here we use a new projection to get square kilometer areas. We divide by 1 million to convert from meters to kilometers squared. Running the cell now. Let us find and color the 5 biggest states. We sort by area, take 5 largest. We plot the USA states in light gray for context. The largest ones appear in dark blue. Centroids help us add their abbreviations. White text makes the labels clear. Title sets the chart theme. Now we show the results. Running the cell now. Which states look largest on your map? Try changing the number to see different rankings. GeoPandas lets us save filtered data for later. Here we write a new file for Western states. File names end with .shp for Shapefiles. Running the cell now. Mini project, map US states with earthquake data. Let us add real earthquake locations to our state's map. We will use a small open dataset from the USGS. Running the cell now. We fetch a CSV of recent US earthquakes. Data comes from a government site and includes magnitude and location. We show the number of quakes in the file. A preview gives the place, shake size, and coordinates. Running the cell now. To add points, we convert table rows into map coordinates. We use their longitude and latitude to mark each location. Now we combine states with quakes in one plot. Each earthquake symbol size matches its magnitude. We use some transparency to keep the map readable. A descriptive title helps explain the map. Let us look for clusters or patterns visually. Running the cell now. Change marker size or color to make the earthquake stand out more. We check which earthquake points fall inside the state of California. We grab CA's shape for the check. GeoPandas helps us test whether each quake is inside. We print the total for this week. Running the cell now. Try changing CA to another state abbreviation. This checks real-world data in a geographic context. Sometimes we want to tidy up by deleting extra files. Shapefiles include many side files, not just .shp. Here we delete each Western_states file extension. This helps keep things organized. Running the cell now. Recap and next steps. GeoPandas lets us read, explore, and plot rail maps. You can filter and style by attribute or location. Save maps or combine with other datasets. You have the basics for working with geographic data in Python. Check out GeoPandas examples and official docs to dive deeper. Running the cell now. Extra, try this challenge. Pick a US state you like. Show a map of earthquakes only in that state from the last week. Label at least 5 largest quakes with their magnitudes. Want more free Python tips? Subscribe to our channel and like this video. Happy mapping! Running the cell now.